Okay, so now we are moving on. We are going to calculate now mass in grams of one substance in a reaction from the mass in grams of another substance. I think I said that backwards, right? Given the mass, calculate the mass of another substance, all right? And so this is going to depend on the law of the conservation of mass and the mole-mole relationships and converting between moles and mass, and that is it, all right? So first of all, when you're given the mass of 1, you're going to convert the mass of substance A into the moles of substance A, right? And then you're going to convert the moles of substance A into the moles of substance B, because that's the only relationship that we have between A and B is moles to moles. That's it, right? So this is key right here. And then finally, we're going to convert back from moles of B into mass, right? So we're going to go from mass to moles, moles to moles, mass to moles, moles to moles. I guess I can put an arrow there, right? No, let me do that. We're going to go, there's my moles to moles right there, and then moles back to mass, right? Where we have the mass of A, the moles of A, right? That's a conversion from mass to moles. And then we're going to go from the moles of A to the moles of B, right? That's what we did in the last conversation, converting moles to moles. And then finally, we're going to go from moles of B to the mass of B, right? Calculating between moles and mass. All right, so this is going to take some practice. Let's get right into it. Suppose we want to determine the mass of ammonia that can be produced from, we want the mass of ammonia that can be produced from 32 grams of nitrogen, right? And we know the mole ratio is 1 to 2. So we're going to have to do some molar mass calculations and then molar mole calculations, and we're good, okay? So what we want is, I'm going to put it all in one big picket fence, the mass in grams of ammonia, right? And we're given the mass of nitrogen, right? So first thing we're going to do is we're going to calculate, I think it's a couple steps like that. I think first thing we're going to do is we're going to calculate the moles of nitrogen using the molar mass, right? This we did a couple lectures ago, right? So mass, these are going to cross off, you can see that, and we're going to be left with moles, right? Then we're going to convert moles of ammonia, because that's what we're trying to get, right? So we'll have to cancel out N2, put moles of ammonia in there, right? And you see that these cross off, and I'm left with moles of ammonia, okay? And then finally, I just need to do another mole to mass calculation by, right, moles of NH3 ammonia, right? Okay, and you can see that my moles cross off, and I'm left with my mass of ammonia, which is what I wanted. This is perfect. Okay, so let's put the numbers in, and we'll be done. So the grams of ammonia we're starting out with is 32 grams. 32 grams, 2 sig figs, by the way. Okay, and then the molar mass of ammonia, it's 1 mole per how many grams? Let's figure that out. Do I still have that periodic table up? No, I don't. Okay, let's go back over here. Periodic table. This is the one I want. Ammonia is 14.007. I'm sorry, that's just the nitrogen, right? 14.007. You see it there? 14.007. Let's go back over here. Oh, it's times 2 though, right? Because it's N2. So it's going to be 28.014, right? It's the molar mass of nitrogen is 2 times 14.007 because it's N2, right? So for every mole of N2, I've got 2 of those. And 2 times 14.007 is 28.014. That's what I got. Okay, good. 28.014, right? And the moles to mass, I get that from here. There's 1 for every 2 moles of ammonia, okay? All right, so, and then my grams per mole of ammonia, there's 1 mole for every how many grams? Let's go back over here. And it's 14.007 and 1.008. Okay, so for ammonia, it's 1 times nitrogen plus 3 times hydrogen. A little messy there. 14.007 plus 3 times 1.008, which gives me 0.007 plus 3 times 1.008 gives me 17.031. 17.031. Put that in here. I'll put it in blue. 17.031 grams for every 1 mole, right? All right, so let's calculate this out and we will be done. $32 divided by 28.014 times 2 times 17.031. Enter. And I get 38.9. 38.9. 38.9 grams of ammonia. I have to report this to 2 sig figs, right? Because these all had more than 2 sig figs. These were exact. But the other measurements had more. So this is going to be 39 grams of ammonia. All right, so let's give you a chance to practice now. How many grams of oxygen are needed to produce 45.8 grams of iron 3 oxide? Okay, pause the video and then come back and compare your notes to mine. Okay, I'm going to suppose that you paused it, and I'm going to say, first of all, oxygen and iron 3 oxide are there. Those are my ratios there. I'm asking how many grams are needed to produce. So I've got grams of O2, and I was given grams of Fe2O3. I'm not sure if I left myself enough room here. You know what? I don't think I did. Let me come over here and say grams of Fe2O3. Set up my picket fence. A little bit ugly here. Okay, so I'm going to get my grams of Fe2O3. It's Fe2O3, right? I'm not going to put it all there. I guess I will. Moles of Fe2O3. Okay. And then it's moles to moles. And then it's moles to grams, right? This is of O2. 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 Fe2O3, okay? So I know my molar ratios. There's my 3 moles. Those are going to cross off. Here's my 2 moles of that, right? And so I've got to come up, and these are going to cross off. I'm going to have to come up with my formula weight, my 45.8. That's what I was given, 45.8. And what's my grams per mole of Fe2O3? I'm going to do it up here. 2 times Fe plus 3 times O is equal to 2 times plus 3 times. I just did this one, so I remember it's 15.999. Let's come over here. Iron is 55.845. 55.845. 2 times 55.845 plus 3 times 15.999 is equal to 159.687. 159.687 per mole, right? And oxygen's 2 times 15.999 is going to equal, probably do that in my head, 2 times 15.999 is about 32, 31.998, should have known that. Per 1 gram, right? Remember, and it's 2 oxygen atoms, right? Because it's 2 there, right? That's why we do that. So I'm going to put this in my calculator now. Hopefully this is what you've got, 45.8 divided by 159.687 times 3 divided by 2 times 31.998 gives 13.766. 13.766 grams of oxygen. This was 3 sig figs, right? 3 sig figs. This was more. These were exact. That was more. This is going to be 3 sig figs. This is going to be reported as 13.8 grams of O2. Okay? If you got something different than that, of course, it's possible I made a mistake, but the more common thing, of course, is I do this so often, I don't get mistakes very often. But if you made a mistake, it's possible that you did not put parentheses around your 3 and your 2 and all the stuff that goes down here. So just be careful. Make sure this is make sure you're putting this in your calculator correctly. And I'm gonna argue you'll get 13.8. All right, so let's close this conversation out with a learning check. Oh, one more learning check. Okay, it's sort of the same thing. Pause the video and do this problem and come back and check your answer against mine. Okay, so I'm going to suppose you paused it and did your answer against mine. It's 13.1 grams of water. We're doing the reaction between H2. How many grams of O2 are reacted if I get that many grams of water? So it's 1 to 2 is my molar ratio, right? And we're asking for how much O2. So the question is going to be O2. And that is grams of O2, right? And we were given grams of water, right? So I'm going to set up my picket fence here. Hopefully a nice straight line. This is going to be grams of water because these have got to cross off. And it's got to convert to, we've got to convert this to moles, right? So we can do that with the molar mass. And now we're going to convert moles of water to moles of oxygen because we need it, right? There's my moles of oxygen. And then finally, we got to convert moles of oxygen to grams of oxygen. Okay, so let's put the numbers in here now, and we will be done. 13.1 grams. This was, we did this a few minutes ago. I still have the notes here, 18.0146 per 1. That was the molar mass of water. The molar ratio is, looks like it's 1, right? There's my 1. And there's 2 moles of water. There's my 2 moles of water. Okay, my grams per mole of oxygen. I just did this in a previous problem. It's 13.1998. I still have it on my paper. And I'm going to calculate that out and get the same number that you got on your paper. 13.1 divided by 18.0146 divided by 2 times 998 gives me 11.634 something, right? 11.634 ... grams of O2. Okay, and I had 3 sig figs here, more there. These were exact, and more there. So it's going to be 3 sig figs. So it looks like I'm going to be reporting my answer as 11.6 grams of oxygen. All right. Let me know if you want to talk more about this, you want more practice problems or more examples. Good luck.